Hello everyone, welcome back to another video. So today we'll discuss editorial for weekly contest 427, and I was able to solve only first three problems. I tried fourth one but couldn't crack it, and my rank till now is 289. It might move up to 350 I think, but yeah. Let's start with the editorial. So problem one. Yeah. The first problem is transformed array. So we are given an integer array nums that represents a circular array. And what a circular array is, that next element of last element would be first element. So that's circular array basically. And previous element of first element would be the last element. So we have to create a new array result of same size, which follows follow these rules. So for each index I, where I is from 0 to nums length, we have to perform some actions. Those actions are, if nums of I is greater than 0, we start with index I and move to nums of I steps to the right, and set result of I to the index where uh, where the current index is landing. Similarly, if nums of I is less than 0, then we move to left in that circular array with steps absolute of nums of I, and if it is 0, then we will just make result of I to nums of I. Basically, we have to shift our index with nums of I based on its value, and the direction would be dependent on, if it is positive it would be to right, if it is negative it would be to left. Now, as it is first question, the expectation would be to have a brute force solution. So this has a brute force solution also, and also has an optimal solution. So let's just see first example and then we'll move to solution. So we are given nums 3 minus 2 1 1. Now for we will start from 0 to 3, from 0 go up to 3, and for nums of 0, if uh, nums of 0 is equal to 3, so from this index we have to move right by 3 steps. If we move right with 3 steps, we reach nums of 3, we reach index 3, and the value of nums of 3 is 1. So new array's value at index 0 would be 1. Similarly, for nums of 1, which is equal to minus 2, we move 2 steps to left. So minus 2 to 1 step would be 3, and to another step it would be 1, as it is in circular array. For nums of 2, again 1 to right, so answer is 1. And for nums of 3, we have to move 1 to its right. So from 3 index, if we move right, we go to 0, and the result of 3 is 3. I hope you might have understood the question now. So the solution which I wrote is simple brute force. What I'm doing is I'm iterating over 0 to n, finding the count number of steps, and I'm just keeping this d as direction. So if I'm declaring d as 1 first, and if a of I is less than equal to 0, I'm making d equal to minus 1. So what d is? D is just an incrementer according to the direction. Now I have created another pointer j, which is initially I, and I'm just simulating the number of steps. So in each step I'm incrementing the index with d. So if it was negative direction, j would decrease. If it was positive, j would increase. Now I have these two conditions to handle the case of circular array. That is, if j becomes less than 0, j will be n minus 1. If j becomes greater than equal to n, then j would be 0. And after performing the count number of steps, I'm just pushing the value which is at index j. So this was the solution to first problem, brute force solution. Now let me explain optimal solution. Let's say I is at index, I is the current index. Now if I move j steps to its right, so my new index would be I plus j. Now this might go above n. Then what can you do in this scenario? What you can do is you just take I plus j mod n. So from index I, if we move j number of steps to its right, and if it is, let's start with the value n itself. If it is n, then n mod n would point to 0. If it reaches 2n, that means 2 rotations, then 2n mod n would be again 0. If it reaches n plus 1, then n plus 1 mod n would be 1. So this is a simple trick or observation which is important in case of circular array. So whenever you increment index with j, just take mod of n with it, so you don't have to run the simulation. So this additional n loop can be it can be optimized with this step. Now similar case would be in case of minus. So when you do minus, you need to take care of this. You need to take care of this value going into negative. Then I minus j might go into minus 1, something like that. So in that case, what you have to do is you have to add a multiple of k, a multiple of n, and this should be very high, such that this number, this negative number would become positive. So what I'm trying to say is, let's say I minus j would becomes minus 1. Now if you add n into it, the whole sum and the sum would become n minus 1. Now you take mod with n, and this would be n minus 1. So minus 1 represents the number before 0, which is in circular case would be n minus 1. So in in while going to left, you just take I minus j, take k into n, where k is a constant such that it always makes this value positive, and then take its mod with n. So this is the case where for moving towards left in circular array, and this is the case when we are moving towards right in circular array. So these are the two optimizations which you can do, but here the constants are very low, so brute force will also work. Whichever comes to your mind first should you should write that. So this was the first question, pretty easy. Now we'll move to second one. Yeah, this is I found second question a bit more difficult. Not difficult, but uh, harder to implement than the third question. You can see that in my timestamps. So I solved first one in 230 minutes. Second one took me 18 minutes, but the third one took me 5 minutes. So second one was a bit difficult to implement for me. So what second question is that we are given points where points of I is two coordinates x and y, coordinates on an infinite plane, and we have to find a maximum area of rectangle that can be formed using 4 of these points as its corners and does not contain any other point inside or on its border, and has its edges parallel to axis. So let's just see an example, this one. So these are the 4 points. And these 4 points itself, we only have one option because size of the given points is 4 itself, so only these 4 can make a triangle. So this is the triangle which it forms, and as you can see there are no points in between the rectangle, in between or on the border of rectangle, except the corners itself. So here the area of rectangle is 2 into 2. 2 is height, 2 is breadth, and the maximum area possible is 4 here. So we have to return that 4. Now we are also given other, in second example we are given 5 points, and these 5 points are plotted like this. Now here only possible rectangle is this one, these 4 points. So all the points except 2 comma 2. But this rectangle cannot be, doesn't satisfy our conditions of no other point present in or on the border except the corners, because 2 comma 2 is present in this rectangle if we form the rectangle with these 4 points, and there is no other way of creating a rectangle. So here answer is -1. Now in example 3 we are given 6 points. These 4 points can form a triangle, these 4 also can form a triangle, but 1 and 3 coordinates, so this bigger rectangle cannot be a, these 4 coordinates cannot make a rectangle and satisfy our condition, because there would be these 2 additional points in or on the border of this rectangle. So here only option is this one or this one, and both have same area, which is 2. 2 is breadth, 1 is height. So answer here is 2. Now if you look at these constraints, you basically, what you need to write is a brute force. So I won't explain the solution here. Let's start with what brute force would consider. I tried to think of any optimal solution because the same question is fourth one. So, but it was of 0.8. So I skipped that idea of implementing the optimized solution and just wrote the brute force for first one. So here I'm declaring n an answer. Now these are the 4 points. I'm fixing 4 corners of rectangle using this four for loops. Now what is the complexity of this? It would be 10 raised to the power 4, as point n is 10 itself. So 10 raised to the power 4. Now I'm just checking if they are all are unique. That means no two indices are in the same, no two indices are equal, so no 2 points are equal, which I am considering. Then what I'm doing is I'm creating a vector of these all 4 points and sorting them out. Now why I'm doing this? Because in, if 4 points are forming a rectangle, two of them would have same x-axis, x coordinate. So this is 1 1 1 1 3. So basically both of them have same x coordinate. So by sorting it, I would find those 2 points on first 2 indices, and other points, so these 2 points would be present on next 2 indices. So basically, to simplify my ordering of these 4 points, I'm sorting it. So let me write those points for better understanding. 1 1. So if I sort this, they would remain as it is, because I wrote them like that. So 1 1 and 1 3, this would form an edge like this parallel to x axis, and 3 1 3 3 would form a uh, edge like this parallel to y axis. And if you connect these dots, this would be my expected rectangle. So after sorting this, I would guarantee that these 2 points have x coordinate equal, these 2 points have x coordinate equal, and by observation of from this rectangle, these 2 points would have same y coordinate, and these 2 points would have same y coordinate. So these are simple conditions for checking if it forms a rectangle. So then what I'm doing is I'm just checking all those conditions. So first x coordinate and second element's x coordinate is equal. Similarly, third and fourth x coordinate are equal. First and third's y coordinate is equal, and second and fourth's y coordinate is equal. If they are equal, at least we can form a rectangle. Now for second condition, that is there are no points in or on the border other than corners itself. Now for that I am declaring a counter, and then I'm iterating over all the points. So here complexity would be 10 raised to power 4 into this 10 raised to power 5. If you consider this sorting also, wouldn't make that much effect, but yeah, overall complexity would be 10 raised to power 5. Oh, I'm checking if a point is in between the rectangle. First of all, these are the borders parallel to y-axis. That means, and these are the borders parallel to y-axis, parallel to x-axis. If a point is here, it must be greater than equal to this limit, and greater than equal to this limit, and less than equal to this limit according to its x coordinate, and its y coordinate would be less than equal to x x coordinate would be less than equal to this, and greater than equal to this, and less than equal to this. Y coordinate would be greater than equal to this, and less than equal to this. Now what this will represent, this will be the last element of our vector. This would be the first element of our vector, second element of our vector, and third element of our vector. So index at 0 1 2 3, because we are sorting according to x element, sorting because we are sorting those coordinates by default comparator. So first smallest x value would come at 0 index. If both are equal, then smallest y value. So 0 1 2 3. Now to check if an point is in rectangle, we check these two limits, and similarly these two limits. So if a of I and 0 is greater than or equal to b of 0 0, which is this minimum limit, and a of I 0 is less than or equal to b of 2 comma 0, which is this. Similarly, a of y coordinate is greater than or equal to b of 0 of 1, which is this, and less than or equal to b of 1 of 1, which is this. I'm just incrementing counter. Now if counter is equal to 4, that means there are only 4 points which are in or on border of our rectangle, and all those 4 points are basically the corners of itself. Then what I'm doing is I'm taking answer with max of that area, and finally I'm returning this answer. There would be definitely an optimal solution for this, which is the answer to fourth question itself, but I couldn't think of it anything for now, but we'll try to solve the fourth problem definitely. Now moving to third question. Third question is pretty easy if you know two concepts. So in this question, we are given an integer array nums and integer k. We have to return maximum sum of non-empty subarray of nums such that size of subarray is divisible by k, and a subarray is just contiguous non-empty sequence of elements. So first, the nums is given as 1, 2 and k is 1. The subarray 1, 2 would be one of the possible answer because it has length 2 which is divisible by 1 itself. So answer here is 3 because sum there is max. Other possible subarrays would be only one element with 1 or 2. The sum would be 1, 2 respectively, which is not maximum. Now in this case, minus 1, minus 2, minus 3, minus 4, minus 5, k is 4. So there are two options. This first one, these four elements which should sum out to be minus 10, and then this one. So this would be minus 14. Maximum of minus 10 minus 14 is minus 10. So here answer is minus 10. Note that answer here is not 0 because we have to return a non-empty subarray. And in third case, we have minus 5, 1, 2, minus 3, 4. And this is the subarray which forms the maximum sum of 4, which has length 4 and which is divisible by 2. So, two concepts. Let's write it down first. One is prefix sum. Second is cadence algorithm. Now, what prefix sum is? Pf of I. So prefix sum is nothing but an sum of elements till I. So if we have to find prefix sum at index I, it would come out to be a of 0 plus a of 1 up to a of I. So this is what prefix sum basically means. Now what is cadence algorithm? So cadence algorithm is an algorithm to find maximum subarray sum. Maximum subarray sum where there is no condition. So we are given an array and we have to find a subarray. We have to find maximum sum of that any subarray in that array. Now, if you want to learn about cadence algorithm, you can go through this GFG article. I mean, I won't explain it here. I will explain what variation of this algorithm is in the question. But you can go through this article and try to understand what cadence algorithm is. Now, first observation, let's start with some observations. One of the possible array would be, let's take one based indexing. So one of the possible array sub array can be 1 to first k elements. Another possible sub array can be 1 to 2k elements. This will go up till 1 to rk, let's say, such that r into k is less than equal to n. Note that we have considered one based indexing. Now, second possible arrangement can be 2 to k plus 1. Similarly, 2 to 2k plus 1. And this would go to up to 2 2 2 uh, 2r2k plus 1, such that 2r2k plus 1 is less than equal to n. Now these are all not only condition, these are not only possibilities. In first case, another possibility can be k plus 1 to k, to 2k. So let's try to write for 3 again. So 3 to k plus 2, or 3 to 2k plus 2, like this. And the last possibility can be k minus 1, first possibility, that is we start with k minus 1 and go till 2k minus 1. Yeah, and 2k minus 1. Let's remove this possibility from here, and kth possibility can be we start with k itself. K to 2k, k to 3k. So these are some possibilities. Now, what this each possibility represents, it represents a end of subarray. What this end is, it is unique, and it lies from, its mod lies from 0 to k minus 0 to k. Let's consider it as x. So let's start with first possibility. We have 1 to k. Then another subarray we can take from k plus 1 to 2k. So we basically divide the whole array into these partitions. So 1 to k, k plus 1 to 2k, 2k plus 1 to 3k, like this. Now we just have to take sum of it, right? So instead of making it a subarray partition, we just make whole sum of it. Let's say it is b1, this is b2, this is b3, and up to br, let's say there were r partitions. Now this problem is now a cadence algorithm problem, where we are given an array and we just have to find maximum subarray sum. Now what we did here was we removed the first condition of divisibility by k, created a new array which is a normal array, and we just need to find its maximum subarray in that new formed array. Now you run cadence algorithm on this. Now this is one of the possibility. Another possibility is you can start your subarray from 2, index 2, in one based indexing. Remember, I have taken one based indexing for better understanding. So from 2 to k plus 1, k plus 2 to 2k plus 1, like this. Again make a subarray b1, b2 up to br2, and take cadence algorithm in this. Now you will repeat this up to k minus 1, because if you do for it for k, it would just repeat the first step. uh, yeah, this one, because here we are considering uh, yeah, not k, but you have to do it up to k. You don't have to repeat it for k plus 1, because k plus 1 would repeat itself in this first step itself. So for k, you have to create subarrays. You have to create arrays like this. Now you would say it would take k into n complexity. Now here you will use prefix sum. So for taking sum of 1 to k plus 1 to 2k, you don't need to iterate the whole array. You just need to iterate endpoints of each partition. So k, 2k, 3k, and rk, where r is such that is less than equal to n by k. So to find subarray from k plus 1 to 2k, you take prefix of 2k and subtract prefix of k. That's the important observation or use of prefix sum is to you can find subarray sum with start point and end point. So let's say you have a prefix sum till I and you have prefix sum to till j. You have to find sum of these elements. What will you do? You will find prefix sum till I and subtract prefix sum till j. So now you will have all the elements after j to i's sum. So you will iterate on endpoints. So k into approximate endpoints would be n by k. So k will cut and approximately complexity would be linear n. So this is the solution for third problem. Two observations. One, all possible subarrays are you can identify them based on its starts values mod with key. Then how can you use prefix sum to optimize it? And once you optimize it, how can you find maximum subarray using sum of subarray using cadence algorithm? 349. Okay, that's not bad, I would say. So this is the code for third problem. First, we find prefix sum, and then we start iterating from 0 to k. 0 to less than k, so 0 to k minus 1. This is our start. I is our start, j is our first partition's end, and then we iterate till if j is less than n, that means at least there is one partition. We will start from that partition. So this is the sum of first partition. We'll take its max with answer, then increment j. Now here from here we will start with second partition. Now this is the part of cadence algorithm. If just add one if condition, that's it. That is the cadence algorithm. And then we add this prefix sum of that new partition and take its max with our answer and increment j with k. So this is of k for loop, and this while loop is n by k because here incrementation is of not of 1 but of k. So it would iterate by with n by k. So k into n by k, n, so overall complexity of n. So this is the solution for third problem. Now fourth one I would skip for now because I was not able to solve it. There are very less solves for this question. We might have to do something with first sorting this with x coordinate and using something like a set, or not sure how can we do that right now, but we'll try to solve it. Yeah, that's it from my side, and thank you for watching.